Okay, so here's a definition of average rate of change. It's one I like to use. It doesn't involve x's and y's. It's more generic, so we don't get hung up on the name of the variable. Okay, so with this definition, the rate of change is z with respect to y, and you just told me exactly, and you did that pretty much immediately. Very good. Rate of change of z with respect to y is change in z divided by change in y, right? Okay. And the change in z is what?
It's f x and y.
Well, when y is 1/2, what's the value of z?
Would it be 1/2?
Yeah.
Yeah. And so if it's 1.
Now, the assumption throughout is that x is still 2, right?
Yeah. Okay.
Okay? So as long as x is still 2, the change in z on the interval, y interval 1/2, 1 is the value at 1 minus the value at 1/2. Okay? And we could write that as f of 2, 1 minus f of 2, 1/2. And where my red chalk is, I'll emphasize that the 1 and the 1/2 are the important numbers here. I mean, it's important that the value of x remain constant, right? Okay? And that's divided by the change in y, which is just 1 minus 1/2. Now, we've already calculated the numbers. This value is 4. This value is 1/2. Okay? So, and, yeah, here's my y interval, 1/2 to 1. That's why we have the 1 minus 1/2 here, and you understand that, because that's a change in y. And the 4 minus 1/2 is the change in the value of z, which is the value of f of xy, right? Subject to x equals 2, so we have the 2 there. Okay? And I can even kind of color code that. 2 is going to remain fixed. So I'll emphasize that. Okay? 2 doesn't change throughout. Because, again, we're asking for the average rate of change, provided x equals 2, and it's the y that's changing. Okay? Make sense? And then, of course, we can do that calculation. It's 7.